Okay, so climate graphs, or as they're sometimes called climatograms, okay, are graphs that show us and give us an idea of not only the temperature and the rainfall or precipitation of an area, but they can also allow us to interpret some of the factors that might affect the climate in that particular area. Yesterday we went over that the components of climate are temperature, precipitation, light, and wind. Okay? Only two of which are directly graphed on a climate graph, but we can kind of infer what the light is like, not so much the wind. Okay? And then we can also infer from the structure of a climate graph what some of those factors would be, like latitude, altitude, okay, mountain barriers, centers of high and low pressure, proximity to oceans, ocean currents, all those things we went over yesterday. Okay? So this first climatogram here is of Manokwari, New Guinea, which basically sits on the equator. Okay? Now, the graph shows the precipitation as the bar graph part, okay, with the scale for the bars being over here. Okay, so this is precipitation in centimeters, right? And then the green line shows the temperature, and the scale for the temperature is over on the right-hand side. Some climatographs will switch that, okay, but they'll always be labeled, so you'll know which one is which. Okay? All right, so in Manokwari, New Guinea, what do you notice about the temperature? Okay, it's fairly high. I mean, it's about 26 degrees or so. Okay, but it's 26 degrees consistently. What does that tell you about where it might be located? Yeah, it would have to be near the equator. Anywhere away from the equator is not going to have a consistent temperature. It's going to have seasons. The further from the equator you go, okay, the more distinct the seasons become, okay, because of the tilt of the Earth. Everyone kind of follow me on that? Okay, that's why we have those two special numbers of lines of latitude, right? The Tropic of Capricorn and the Tropic of Cancer. Okay, they're 23.5 degrees north and south of the equator. Between those two lines, there's effectively very little seasonality. Above those lines is where seasonality starts to show up. Okay? All right, so we can tell from the temperature line that this is probably something near the equator. This is something you're going to have to do on your unit exam. If I give you a climate graph, okay, I'm going to expect that you can tell me something about where that climate graph comes from. Okay, so if you saw something that had a flat line, you'd be able to tell me right away that it's probably near the equator because there doesn't seem to be any distinct seasons. Right? Now, if we look at the precipitation, okay, what do we notice about the precipitation? High or low? It's pretty high. Okay? I mean, if you're looking at the scale here, their driest month, okay, which is October, so this would be in the tropical rainforest, the dry season, in air quotes, okay? They get 11 centimeters of rain. Okay, to give you an idea, in 2013, when we had the floods, okay, we got 14 centimeters of rain. Okay, so their driest month would be torrential flooding here. Okay, so very, very wet climate there, right? Their wettest month, they're getting 33 centimeters of rain in a month. Okay, like if you just, if you dug a hole, you could fill it in a couple of days just by leaving it open for the rain. Okay, it rains that much. All right, so from there, okay, like from just looking at that, we can say this is obviously a fairly wet climate. There's a lot of precipitation. There seems to be some parts of the year where there's more than others, okay, but generally it's very wet, generally it's very warm, okay, and you might even be able to give me an idea maybe of what biome, when we go over those, it would come from. Okay, so this would obviously be the tropical rainforest biome. Okay, everyone kind of follow me on that? All right, now, if we look at the next one over, okay, it is a mid-latitude deciduous forest. So that's the biome, the deciduous forest biome. Okay, it's Nashville, Tennessee. Okay, so it's about halfway up north-south in the United States. Okay, it's in the Midwest, so it's a little, they call it the Midwest, but it's actually more east than west. Okay, and we can see that the temperature line makes a curve. Okay, what does that tell me?
On the equator.
It's not on the equator. Okay? There's distinct seasons. So the latitude here is definitely more than 30 degrees north or south. Actually, it has to be 30 degrees north. How do I know that? If it was 30 degrees south, what would the curve look like? Yeah, it'd be backwards. Well, actually, not opposite. Well, sort of opposite, I guess, yeah. Okay, your hottest months would be up here, and the curve would go like this because the seasons are swapped, okay, in the southern hemisphere. All right, so this is a northern hemisphere, mid-latitude deciduous forest. Okay, we know that it's got distinct seasons, but the winters are pretty mild. Okay, coldest month is about 6 degrees Celsius, not too bad. Okay, the warmest month is 28 degrees, so pretty hot summers. But what do you notice about the rainfall? We would say not a lot, but I mean, there's enough there, and it's pretty steady, right? Like, they don't have a season that's distinctly drier than another, right? They get pretty steady rain all year long. That's what you need if you want to have a deciduous forest growing. It needs regular inputs of rainfall. Okay, everyone kind of follow me on that? Okay, that's the kind of interpretation we would have to do. All right, and then another one that would be even further north would be Anchorage, Alaska. We still see the bell curve, but it's shifted down. All right, if this was, like Anchorage, Alaska is actually fairly mild for as far north as it is. If this was like Alberta, okay, or something like that in Canada, that line would be even further down. All right, so distinct seasons, it's in the northern hemisphere. Coldest month, -10, okay? Warmest month, only about 15 degrees, okay? So pretty cold, okay? Definitely a northern climate. And fairly dry, with the wet season being actually in the late summer and early fall. All right? Not too tough to interpret those? Okay, so the other thing we would want to get from that is, again, those factors that affect climate. We can tell latitude by the shape and location of that bell curve, or the lack of a bell curve. Okay, we can tell, maybe if it's near an ocean by the amount of precipitation. Okay, things like that. Okay, everybody all right with that one? Okay, so then let's talk about your climate graph activity. All right, so this isn't like a real lab. Okay, it's going in your lab's category of your marks, but it doesn't have a manipulated, responding, or controlled variable, so there's no design part to it. Okay, there's going to be a hypothesis, okay, where you're going to make an if and then statement about what factors you think most affect climate in Canada. Okay, so it would go like, if the following factors affect climate in Canada, and what we're doing here is studying basically climate graphs of Canadian cities, okay, then tell me some patterns that you think you might see. As an example, one pattern might be that the cities that are furthest north will be the coldest. Okay, or the cities with the highest latitude would be the coldest. Just name 2 or 3 patterns in the then part that you think you'll see. Okay, thinking about some of those factors that you named in the if part. Okay, so pick 3 factors for the if part. Talk about what the patterns from those factors will be.
Why is it due December 8th?
Oh. Yeah, it says it's December.
Oh, December 8th.
Yeah, I was
trying to make it January 8th. Hang on.
Yeah, so it's just.
I'll fix that
It says
later.
that it's
I'll fix it later. Fix it later. Okay. That's what happens when I'm trying to do it in a hurry.
a glacier.
Okay.
No, we talked about it yesterday.
Hey, listen. All right, so here's what you're doing in this lab, or in this activity. Okay, you are going to have a whole bunch of climate graphs, okay, including these 3, okay, that you are going to have to look at and then, based on their shape, group together. Okay, now there's a lot of climate graphs, okay, but you and your group can start looking them over and deciding which ones you think should go in a group together, okay, just based on their shape. All right, once you've made those groups, then I want you to go to Google Maps, okay, and on the satellite view, look at where they are, okay, and see if, by some miracle, they happen to be near each other and maybe are affected by similar factors. Okay, so what your end product here is going to be is a list of groups. Okay, in those groups will be cities. Okay, and then underneath those cities will be a description of that climate group. Okay, you can give it a name, like for example, if by some shocking pattern that all of the cities in Atlantic Canada end up in the same group. Okay, that you might say, this is the Atlantic group. And the factors that affect the Atlantic group are, and then you tell me what they are and how they affect the climate. Okay, so you have a list of cities for each group, and a description of the factors that affect the climate of that group and how they do it. So that would kind of also tell me what that climate is like. Is it rainy? Is it cold? Okay, that kind of stuff. Everyone follow? So that's what I'm looking for, is kind of an end product of the procedure. Okay, is groups, cities in the group, what factors affect that city the most, and how they make the climate what it is. Okay? All right. So if you're doing this well, okay, you should probably have somewhere between 5 would be the minimum, 8 groups, between 5 and 8 groups, okay, for the cities. If you have anything less than that, you're not trying hard enough to find the differences, okay? Because I once had a person, they handed in their thing and they were like, Pacific climate and Atlantic climate, and like Edmonton and Calgary were in the same group as Vancouver. I'm like, try harder, okay? Like those cities definitely don't belong in the same group. Their climate is nothing alike, okay? There should be at least 5 different groups, and you can make an argument for, even if you're being really picky, 8, okay? All right. So, as I was saying, with your group, you're going to look at the shapes of the climate graph. So you've got these 3 here, okay? One is Vancouver, one is Medicine Hat, okay? One is St. John's, okay? So if you look at that one, right? And then on the next page, you will find, okay, other climate graphs. Okay? So if I'm looking at like the first 3 climate graphs here, okay? This one, and this one. Right? So I'm looking at the rainfall. The rainfall pattern is quite similar for all 3 of those. Would you agree?
Yep.
Okay? And the rainfall levels, also look at the scale. Okay, don't just go by what the pattern or the shape looks like. Okay? So the wettest month is like 130 millimeters. The driest month is about 80. Yeah, it's about the same. This one's maybe a little bit wetter, but it's generally the same. This one's, about the same as that one. Yeah, okay, their temperatures, -5, -5, plus 16, plus 16, 20, that one's a little warmer. But I think you could make an argument that those 3 should probably go in a group together, yes?
Yeah.
Okay, and plus, if you look at where they are, Halifax, St. John's, Newfoundland, and Charlotte, and PEI, yeah, they're probably going to be affected by the same factors affecting climate. Yes? Yeah. Okay, so look through the rest. Don't just say, oh, those are the only 3 that should go in a group. There might be some others. Okay, look through the climate graphs and see if you see anything else that kind of fits that pattern, and if you do, you can put it in a group with them. Okay, there's a whole bunch, but I couldn't find the same type of climate graph for all of them, so some of them look a lot different. Okay, like for example, these ones for like Inukjuk, Thunder Bay, okay, Montreal, all those ones. They're still, a climatogram. You've got your precipitation on here and the temperature on here. Okay, the lines are always going to be temperature. The bars are always going to be precipitation. Just make sure you look at the scales. Okay, so that'll give you an idea. So look through the charts. Okay, put cities in a group. Then look them up on Google Maps. Okay, on the satellite view to see if there's things like mountain barriers or large bodies of water. Okay, or things like that. Those factors that affect climate. Find a few, let's say 3 at least for each group. Talk about how they affect the climate, what the climate is based on that. Everybody with me there? Okay, that's the part that takes the longest. Okay, putting them in the groups, that takes a little while, but doing the research, that takes a little bit longer. That's why you're going to have the class after we come back to work on this as well. Okay, now if we go back here to the lab itself, okay, that is basically your procedure and analysis. Okay, so the procedure there, okay, can be divided into groups, okay, locate the cities, right, all of that stuff, okay, group the climates, okay, and then after you've got those groups, question number 2 is going to give you a few more cities, okay, but it's not going to give you the climate graphs for them, right, so here's where geography is going to come into play a little bit, okay, so if I tell you, put Dawson, Yukon into one of your groups, okay? You've got to go onto Google Earth, Google Maps, find Dawson, Yukon, and go, okay, is it close to any of the cities that I have in a group? Which group? You should probably go in that group then. Okay, tell me why. Okay? Everybody all right with that? All right, so just make sure you do this part. Explain your reasoning. Dawson, Yukon should go in this group because, okay? Cambridge Bay, Northwest Territories should go in this group because, okay, give me a little explanation. All right, questions from you guys? Okay, there is a conclusion that you have to do, okay, copy and paste your hypothesis, okay, were those factors you identified the big deal, okay, tell me why, and there's no sources of error here because obviously we're not performing an experiment, this is a data analysis, okay? All right, have at it. You can work together on this, guys. I totally expect that that's the way you're gonna do it, okay?